Welcome to our Spring Boot Quarkus demo. This demo has two parts. Part 1, where we take a Spring Boot application and a functionally identical Quarkus application and compare their startup times and memory consumption. Quarkus has two modes, JVM mode and native mode, that will compare with Spring Boot and show just how much faster and how much lower memory consumption Quarkus has. We then demonstrate a really cool capability of Quarkus, live code updating, meaning you don't have to rebuild and restart your application to see your changes. They're available once you save your source file. This is revolutionary in Java. Part 2 of the demo takes an excellent use case of Quarkus in native mode, that is as a serverless workload on Kubernetes. In our case, the industry-leading Kubernetes distribution, Red Hat OpenShift. The applications are very simple, comprising a simple get greeting endpoint. This is the Quarkus one, and this is the equivalent Spring Boot one. Both Quarkus and Spring Boot use a Java bean called greeting, containing a couple of fields that are basically used to serve out the JSON payload. That's the Spring Boot, and there's its equivalent in Quarkus. The instructions for this demo, as well as the code to run it, are available here in my repo, TNS Corcoran off github.com, and then Spring Boot Quarkus Serverless. Alright, let's get started. So the first thing that I want to do is I want to export my current directory, which is the directory after I cloned the repo and changed into the repo directory. This contains two sub folders, both containing Maven projects, one Quarkus and one Spring Boot. So the first thing we're going to do is start with Spring Boot, and we're going to change directory into the Spring Boot subdirectory, and we're going to do an MVN package that's going to create a jar file that will run in the next step. After we've done that, we're going to start up our application. Now we're going to make a number of recordings on timing and memory in the various different modes for Spring Boot. And we're going to save those values in this sheet here, and we're going to analyze those later. So Spring took about 2.5 seconds, that number there in milliseconds. Next thing we're going to do is we're going to record the resident set size, or the consumed RAM. We can do that with this command here. You can see that it's consuming about 625K of RAM, or RSS, resident set size. Just to prove that we do have a running application. This is the same endpoint, is going to hit both applications. And we can see we've got our Spring Boot Hello World returned. So that's the Spring Boot baseline, if you like. I'm going to shut down Spring Boot, and I'm going to start up Quarkus in native mode, or in JVM mode first. As you recall, there are two modes of Quarkus. So I change into my Quarkus Hello World, and I package up the application into a jar. And then I run that jar. And I record my startup time, 620 milliseconds. And again, I'm going to record my resident set size on my second terminal. $110K. We're going to analyze these later. And let's see, the same endpoint gives us a Quarkus Hello World. Next thing we're going to do is we're going to start up Quarkus in native mode. Now we need to compile to native executable within our IDE, which can take a few minutes. So what I've done is I've done that previously, so now I'm just going to run this native executable. You can see here that startup is in 16 milliseconds, which we record. Again, analyze our resident set size. $18K in consumed memory. Final thing before we do our analysis is just make sure that we have a running application, and we do. Still Quarkus hello world. So let's go up and look at the values that we've just recorded. So our baseline, Spring Boot, startup in 2.5 seconds. In JVM 620 and in native 16 milliseconds. So Quarkus is 4 times faster in startup than Spring Boot, and Quarkus native is about 160 times faster in startup. In memory, 625K in Spring Boot, 110 and 18 in Quarkus native. So we consume about 17% of the RAM resident set size in Quarkus JVM mode, and only about 3% in native mode. So these are truly compelling figures. So next thing we're going to do is we're going to demonstrate a very cool capability of Quarkus, which is live code update. So ordinarily with a Java application, you need to restart and you need to wait a few minutes, sometimes depending on the size of the application, to see your changes. That's not the case with Quarkus. So when we start up here in using this Quarkus dev Maven profile, it allows us to do this live code updating and saves a lot of time. So let's see what our application is serving back by default. Probably going to be, Quarkus hello world. Now I'm going to make a change to my source file. I'm just going to say and save the file. Make a simple change like that, and we can see that it's immediately reflective, which is very cool, and can save you a lot of time throughout the day if there's multiple changes that you're making. So next thing we're going to do is our second part of our demo, which is we are going to push our application up to a shared repository, in my case key or quay.io, and we're going to pull down that image, and that image will be the native image that we've created earlier, and we're going to pull that down into OpenShift and run it as a serverless workload, which is a very excellent use case for native because it can scale down to 0, and it's so lightweight and fast at starting up that it can idle down to 0 and not result in a poor service to anybody who's hitting it and waking it up from idle. This is a Docker file that's contained with the repository under the Quarkus project that basically will take my native executable that I created earlier, package it up in this Docker file into a container image. Using that container image, we use Docker build. We could also use Podman build. Prior to this, we will have logged into our remote repository, key.io, in my case, or quay.io. And so we simply build the container image, tag it, and push it up in this way up to my remote repository. Here you can see the Quarkus native image that I pushed up to Quay, called Quarkus Serverless, and if I drill in here, you can see the image identifier, the fully qualified identifier that I would use to pull that using Docker, and we'll also use that same fully qualified name to pull it into OpenShift. So let's switch across to OpenShift. I'm logged in as an administrator, and the first thing that I want to do is provision my OpenShift serverless operator. I go to my operator hub, where there are a series of a few hundred operators available for me to choose from as an administrator. Operators are Kubernetes constructs running in containers that effectively do the same work as human operators. That is, they install, update, upgrade, backup, recover from failure, and fine-tune complex applications at runtime. They're a massive part of OpenShift, and it makes its install and its use and the use of the applications on top of it very, very simple. So as an administrator, I can create the operator in Operator Hub for serverless. And once this operator will be provisioned by me right now, the administrator, it'll then be available for consumption by users, typically developers. So I'm going to search for serverless, filter on that, and I'm going to select the OpenShift serverless operator. I'm going to go ahead and install that, and I'm going to choose 4.4, which is what my OpenShift version is. A couple of minutes later, my operator is available, as you can see. Knative is the open source serverless engine underneath OpenShift serverless. And Knative supports both serving and eventing application types. Our Quarkus application is a conventional request response serving type of application. So that's the API that we'll use shortly. Before that though, we need a project or a namespace called Knative Serving to house our serving capabilities, and it needs to have that project name. So I'm going to go to my project view. I'm going to create a project called Knative Serving. I'm going to go back down to my installed operators, which the operator will get copied very shortly. I'm going to drill in. I'm going to create an instance of Knative Serving off this API that the operator exposes in this namespace or project called Knative Serving. Go ahead and create that. Down in my pod view, you can see that it's starting to create the containers. They'll be ready. Those type of errors will be fixed within a minute. So I'm going to pause the recording. Now, a couple of minutes later, all of the pods in my Knative serving set of capabilities are running, and they're all ready. So now we can move on. First thing that we want to do is we want to create a application or a project to house our application. We call it Quarkus Serverless. I'm going to create that project, and I'm going to switch across now to the developer perspective. I have a number of different options for creating containerized applications, from a Git repo, from the catalog, from a Docker file, directly from YAML or a database in the catalog. But I'm going to choose the container image that we pushed up to Quay earlier. This one here with this identifier. I'm going to pull that down. First thing it does, it validates that it is available to it. And I have 3 different deployment options. We're going serverless, and I'm going to choose Knative service. Here we also get options on the minimum number of pods and the maximum number. I'm going to go with the defaults that allows it to scale down to 0, so that in idle times our application will save on resources and allow us to do to create a greater density of applications on our server, on our cluster. So I'll go ahead and I create that, and that will be available to us in a couple of minutes. About a minute later, our application is available, as you can see by the solid blue circle, and we can test it out using the route that OpenShift gives us, and we just append greeting to the default path, and there's our application. What serverless will also do for us is, after an idle period of around 30 seconds, it will scale that down to 0. So I'm going to pause the recording for now. So now you can see our application is beginning to scale down. It's going into idle mode. Not yet there. The blue circle is turned to black. Shortly that will be completely gone and it will be idle. And now you can see it's completely scaled down, ready to be scaled up again very rapidly if needed. So in summary, this has been a demonstration on some of the local capabilities of Quarkus, comparing it to Spring Boot in startup and memory, and also the local capabilities for a developer, live code updating. Then we've illustrated an excellent use case for Quarkus in native mode, that is as a serverless workload on Kubernetes, in our case Red Hat OpenShift. As I mentioned in the start, all of the instructions and the code for this demo are at this repo, TNS Corcoran, Spring Boot Quarkus serverless. Thanks for watching.